Okay, all right. A very good evening to all our participants who joined our Penang State Astronomy Quiz Competition for Primary Schools 2021. So we had the final round this morning at starting at 9 o'clock in the morning to 10:15. So today we have the final round, and the final round we have two sections. Section A with 10 objective questions and Section B 5 subjective questions. So today with me, I'm Lai from Astronomical Society of Penang, and together with me is Dr. Chong, our president of Astronomical Society of Penang. Dr. Chong?
Yeah. Oh, very good evening to everyone. Salam mesra, 大家好. So, Mr.
Okay.
We will have a short discussion
So me and Dr. Chong, we are the one who set the question for the final round as well. All right. So today we will discuss selected questions before we announce the results. Before we proceed to the closing ceremony and announce the results for the quiz today. So please keep in mind that we are not providing the answer schemes to anyone. So if you wish to know the answers for the selected questions, please stay tuned to or please pay some attention to our discussion, which will begin in a short while. All right. So we will conduct the discussion in mixture of language. All right, will be in Chinese, Malay, and English. So yeah, I think let's start now. So I'll start sharing the screen. So the first question we selected for this, all right. So it's question from section A, question number 2.
All right. Which is an object.
So the question says that Tom has great interest in astrophotography. With a DSLR camera and a Dobsonian telescope of 8 inches aperture, image of which of the following objects are possible to acquire by Tom? So yeah, this is a little bit about astrophotography. All right, maybe some of you might argue that you all have no experience in the astrophotography, but honestly, all right, besides astrophotography, all right, we should have some idea on what are those objects and whether is it possible to be captured. So the first one is a pulsar, a black widow pulsar, 脉冲星, all right, which is located 6,500 light years away from Earth. All right, and the size is about 2 times solar mass. That means 2 times our sun. So imagine if you are trying to capture the image of Pluto using an 8-inch Dobsonian. Even observing a Pluto using 8-inch Dobsonian is very difficult. So for objects which are further, right, 6,500 light years, 6,500光年以外的物体，就我们要拍摄冥王星都已经是非常困难了，甚至要用这个8寸的这种望远镜反射式望远镜来观测冥王星已经是非常非常辛苦了。那么6500光年以外的天体，那更不用说，那肯定要观测也非常难，何况是拍照呢？所以一般上脉冲星 pulsar, all right, we detect pulsar by radio telescope. That means we measure the radio wave instead of optical telescope. So to see with our eyes is quite impossible, but to detect the signal is possible. So we use very powerful radio telescope. We can detect pulsar. Okay, and then Kepler 160d. Kepler. So this one is an exoplanet. All right. So even our Hubble Space Telescope, it's impossible for Hubble Space Telescope to capture the image of an exoplanet. All right. So how we actually detect exoplanet? We use the technique called transit method, 就遮眼法. How that means we observe a star, we have a star, we observe the star, we measure the brightness of the star. Okay, so when we have exoplanet pass through the star, the brightness will become, the star eventually will become dimmer. 就是说它会变得比较暗，它的亮度会减低。那么亮度减低，然后之后又亮回。So the brightness decrease and then it brightens again. So this shows that there are some object passing through. So this one is most likely it's the exoplanets of the star system. So Kepler 160d is also impossible. Orion Nebula and Pleiades, using telescope we can observe. 用普通的望远镜，就从地球表面上我们可以看到，就猎户座的星云，还有这个昴星团都行。那么还有就是 Venus. It's possible to observe Venus from Earth. Even with naked eye, we can easily see Venus. But then the clue over here, all right, the trick over here, 就是这是一个陷阱啊。Is midnight. Okay, 半夜 midnight. Okay, that means at midnight, Earth is over here, you are somewhere over here. So your visible range is somewhere here.
Yeah.
So if Venus is inside, that means inside, the orbit is inside Earth. Okay, so it's before Earth, it's nearer to the sun. So when you are somewhere here, it's impossible for you to look through the Earth to observe Venus. 就你不可能透视地球来看到金星。所以 midnight to observe Venus is not possible. So the answer is C and D. So maybe Dr. Chong, can you slightly summarize with Bahasa Malaysia?
Ya. So yang soalan ini ialah kita ini adalah hobi astrofotografi. Jadi guna kamera DSLR, digital single lens reflex. Kami berdiri atas bulan bumi di sini. Planet itu ketiga di sini. Bolehkah kita nampak ambil gambar semua objek ini? Jadi jawapan yang betul adalah Orion Nebula boleh. Kerana Orion Nebula ialah di burus Orion. Jadi bolehkah nampak burus Orion waktu malam, tengah malam? Boleh. Jadi boleh rakamlah dengan kamera. C, betul. Tapi ini soalan ini ada dua jawapan. Kedua ialah Pleiades. 7 adik-beradik, the seven sisters. Ini pun boleh tengok di langit malam, tengah malam. Tetapi yang pulsar ini macam Mr. Lai sebut, kena guna teleskop radio. Ini dirakam oleh teleskop radio yang canggih. Jadi DSLR kamera tak boleh nampak. Okay? Kepler ialah sebuah exoplanet. Exoplanet guna teleskop besar canggih. Dua kaedah, satu ialah yang Mr. Lai sebut transit photometry, lagi satu ialah dipanggil spectroscopic method. Nah, ini yang kita gunakan kamera biasa tak boleh buat itulah. Jadi tak boleh rakam Kepler 1604 exoplanet dengan kamera DSLR. Lagi Venus tak nampak. Kerana ini tengok bumi ialah planet ketiga. Tengah malam itu Venus ialah dalam orbit bumi. Jadi ini Venus katakan di sini ialah interior conjunction. Jika Venus di atas sana ialah superior conjunction. Jadi inilah jika waktu siang pun tak nampak kerana Zura ialah itu langit siang. Jadi tengah malam langsung tak nampak itu Zura. Jadi yang betul adalah C, Orion Nebula, dan D, Pleiades, 7 adik-beradik. Okay?
Okay. So just to share a bit on this. Okay, so this is Pleiades, this is Orion Nebula.
Wonderful, nice, very nice.
Yeah, okay. This is some photos taken from some astrophotographers in the world. All right. So next we go to question A5, which is a question by Dr. Chong.
Okay, I read in Malay first, then now you explain in English. Hari ini adalah 17 Julai 2021, Sabtu. Itu 21. Dari kedudukan matahari dan melihat ke arah bumi terletak di sempadan dua burus. Apakah dua burus ini? Katakan kami sekarang berada di atas permukaan matahari. Dan katakan kami ialah Superman, Supergirl lah. Tak takut kepanasan matahari. Dari matahari tengok ke bumi. Jadi bumi ialah di antara dua burus. Jadi yang betul ialah antara burus Capricornus, the sea goat, ialah kambing laut, dan juga sempadan Sagittarius, anak panah, the archer. Alright. Jadi sekarang sini, jika bagaimana kita katakan kita boleh ingat itu peta bintang. We can remember the star chart. Jadi on today, the sun, matahari siang ialah di antara burus Cancer dan Gemini. Daytime, the sun is in Cancer and Gemini. Therefore, from the sun looking at the earth at night time, so you have to add another 12 hours. Jadi sempadan Cancer, Gemini, tambah lagi 12 jam, 180 darjah tambah kita sampai ke sempadan Capricornus dan Sagittarius. Ini Gemini bukan, alright? Dan itu Scorpius pun bukan, Taurus pun bukan, alright? Dari sempadan Capricornus dan Sagittarius. Itulah dia line eclipse.
Yeah, so that means today, okay, today. So imagine we are standing on the sun and look towards the earth. So this is the sun, all right? This is the sun, you're standing here, and this is the earth. So you will see behind there are two constellations, and earth is in the center of these two. So what are these two? Which is Capricornus and Sagittarius, all right? So Capricornus and Sagittarius. Okay, next. Dr. Chow?
This is interesting. Ini soalan berkenaan dengan exoplanet. Saya baca. Banyak exoplanet di dalam galaksi Bima Sakti telah ditemui oleh ahli astronomi. Hingga hari ini lebih kurang 5,000 exoplanet sudah ditemui tahu. Salah satu penemuan yang paling menarik dan mengujakan adalah 7 exoplanet yang ditemui mengorbit bintang kerdil merah yang sangat sejuk bernama TRAPPIST 1. Bintang TRAPPIST 1. Mengapakah penemuan ini menarik dan mengejutkan ahli astronomi? So this TRAPPIST 1 star is very famous in exoplanet research. Mengapa? Now look at the correct answer first. Like you scroll up. What answer ni? Can look at the correct answer. Okay, correct answer is ketujuh exoplanet tersebut adalah planet batuan dan 6 daripadanya telah terletak di dalam zon kehidupan bintang kerdil merah yang sangat sejuk tersebut. So in other words, out of the 7 planets orbiting the TRAPPIST 1 star, they have confirmed that 7 of them are rocky planets, like our Earth lah, like Venus, like Mars, like Mercury, right? And 6 of them are in the habitable zone. Zon kehidupan ialah bermaksud jika ada air di sana, air ialah dalam keadaan air cecair. So in the habitable zone doesn't mean that there must be water, but if there is water, it should be liquid. So that's called a habitable zone. So that's why you're interested. So you go and look at the ABC. A tak betul. You see air cair telah ditemui di atas tempat daripada exoplanet tersebut dan isyarat radio pintar telah. No, the first part of the wrong. Liquid water was already discovered on the 4 exoplanets. They have not discovered yet. Alright, not discovered yet. So wrong. So all the 7 exoplanets are rocky planets, and liquid water was discovered on 3 of the exoplanets. No liquid water discovered yet. They only say that 6 of them are in the habitable zone. Okay, go to C, answer C. Alright, antara 7 exoplanet tersebut, salah satu sangat merupai bumi dari segi jisim, saiz dan kehidupan. No, tak betul. Alright, they have not found any of these exoplanets which is very similar to the Earth. They have not found, alright? Because why? Our present exoplanet search technology not so great, not so powerful lah. So yang betul ialah E. Ketujuh exoplanet tersebut adalah planet batuan dan 6 daripadanya terletak di dalam zon kehidupan bintang kerdil merah yang sangat sejuk tersebut. Okay.
Right? So just add on a little bit. This is the TRAPPIST 1 star system.
Yes.
All right. So habitable zone, that means within the green zone. All right. So you see B, C, D, E, F, G is within the green zone, which is the habitable zone.
I just want to add on that. The TRAPPIST star exoplanet system is actually very small. Between the red dwarf in the center, which is TRAPPIST 1, to the planet H, it's all within the orbit of Mercury around the sun, you know. So you can put the star TRAPPIST 1 and the 7th planet all within the orbit of Mercury. So it's very close to the star. But because it is still got a star, a rich dwarf, though between the what you call the second to the 7th what you call exoplanet is in the habitable zone. All right. So although you see here this is 4 habitable zone, but the latest information I checked last month, 6 of them are in the habitable zone. Only the B, the closest one, is too hot, too close. The rest are in C, D, E, F, G are in the what they call habitable zone. So how do they name it? Remember, exoplanet terminology is like that. You see the star is TRAPPIST 1 star, The first planet is TRAPPIST 1b, Bangkok B. That's the meaning. That's the first exoplanet around TRAPPIST 1. The second as well is TRAPPIST 1c, B, and so on. Okay.
OK，所以简单的说就是从这个是 TRAPPIST One 的这个星系那么从有6个，就是除了 B 以外除了 B 以外就太靠近了它的这个母星之外，从 TRAPPIST EC 到 EH 它都是属于宜居地带这个就是一个 TRAPPIST One 的一个星系的一个图So we proceed to the next question.
Yeah. Right.
All right. So this is my question. All right. So before we proceed, just a soft reminder for all our audience who are watching our live session. So if you have any questions, feel free to ask through the chat session or the comment section on your Facebook page.
And
right?
YouTube also.
Yeah, the chat session, the YouTube, and then the comment section in the Facebook page. So this is question number 8 in section A. So in space, astronauts will have a special experience called weightlessness due to microgravity effect in space. So under certain circumstances, it is possible to experience weightlessness on Earth. So in which of the following circumstances would a person feel weightlessness? That means weightlessness is a very special experience. That means you will not feel your weight. That means your weight is zero at that condition. Your weight is zero. So how? Okay, so there are a few ways to experience weightless. That means 你要体验失重的话有几种感觉第一个就是 free fall， 就是自由落体。So that means you are falling freely from a very tall, from a very high altitude. So free fall. So if you want to experience that, all right. So free fall, you can go to Penang Tech Dome. We have the G drop, which is a vertical slide. So that few seconds in between, you can experience the weightlessness. All right. But please make sure your safety. You want to try any free fall, do not try at home.
Yeah.
All right. So 要体验失重的话，就是要自由落体。So to experience free fall, among this answer there are two. One is skydiving. So before the parachute open, 在你降落伞打开之前，降落伞打开之前，那你就是自由落体。That means you are free falling. All right. Number D, bungee jump. Okay, bungee jump is an extreme sports. So that means you jump from you tie onto a rope and then jump from very high. So usually they jump from top of a tower or they jump from a cliff. All right, so they call it bungee jump. Okay, and then E is the method that neutral buoyant condition in a big deep swimming pool. This is how the astronaut, used to have the microgravity training. So that means because in space they are weightlessness, but they still have a lot of work to do. 就是他们在太空的时候，他们有很多工作要做，都是在失重的环境下进行的。所以在这种情况下，他们要在陆地上的时候，他们就要学进行训练。那么怎么训练？就在一个极大的游泳池里面。那么这个游泳池里面呢，它是中性浮力 ，that means neutral buoyancy. Okay, that means at that condition, the astronaut cannot. The weight is there, but then they cannot feel their weight. So use this to simulate, all right, 来模拟这个失重的过程。So the answer is C, D, and E. All right. So Dr. Chong.
Di ruang ini soalan A8 di ruang angkasa ini berkenaan dengan space exploration. Di ruang angkasa, angkasawan dan akan mengalami sesuatu yang istimewa, yaitu berada dalam keadaan tiada berat, weightlessness condition. Badan disebabkan oleh kesan microgravity di angkasa. Now, microgravity bermaksud ada gravity tapi gravity sedikit. So, actually here, microgravity bukan katakan itu tarikan gravity berubah. Sebenarnya yang betul adalah mikropecutan. The correct word is micro acceleration. Right? The slight acceleration here and there. Okay. Dalam keadaan tertentu adalah berkemungkinan untuk mengalami keadaan tiada berat badan di atas bumi. Keadaan-keadaan berikut yang manakah seseorang akan merasa tiada berat dalam. Jadi inilah tiap-tiap hari dalam kehidupan kita, kita boleh merasai weightless. Contohnya, saya sekarang naik satu kursi loh. I'm on the chair, 1 meter taller on the floor. I'm standing on the chair, 1 meter from the floor. I hang a picture on the wall, and after that, I don't come down from the chair. I jump from my chair. So that 1 meter from the chair, I jump down to hit the ground. That 1 meter, maybe 0.1 second, I'm in weightless condition. But why didn't put the question like that? If you say jump down from a chair, yes, that 0.1 second is weightless condition. But di sini yang betul ialah C, sebelum payung terjun dibuka semasa terjun udara, right? So you jump from an aeroplane, ada payung terjun. So when you're jumping, you open. What do you call this? But this is assuming tak ada rintangan udara. There's no air resistance. Thing to count air resistance, you can feel the force, you know. But imagine there's no air resistance, so it is weightless condition. D, bungee jumping. Bungee, when you drop the time, you drop from 0 speed, you fall a long time, you are like 0 G, you know, right? Ada berat. E, keadaan keapungan neutral di dalam kolam renang yang besar dan dalam. Macam saya sebut tadi, bila itu angkasawan, kosmonaut, taikonaut buat itu training, latihan, dia masuk dalam suatu kolam renang, dia terapung. Tak turun, tak naik. Kerana dalam air itu, dia tambah garam. So they add salt into the water so that the density of the salt is equal to the density of the astronaut and the spacesuit. So what happens to the astronaut in the salt water? Float lah, doesn't go up, doesn't go down. So when the astronaut move the arm, he's floating there, not moving anything, like in 0 G condition. Alright? So that's the correct answer. So this one is A, lift memecut ke bawah. No. Yang bila ada pecutan besar, bukan weightless. Kapal terbang memecut semasa mendarat. When the airplane is landing, boom, with acceleration, that's not weightless condition. Alright? So yang betul adalah C, D dan E. Okay.
Dr. Jung, just to add a little bit comment, why I don't want to put jumping up down from the chair, because this one is dangerous. You know, later the kids try at home.
I want to add on, you know, like you see, in USM you have a kolam renang, you know, but the big one don't have. But the smaller renang, the old one, there's you go to 1 level, 2 level, you jump. No, I time when you jump down about 2.5 seconds, you know. So you are a diver, dive from the second floor to down, 2.5 seconds, you are actually in weightless condition.
Yes.
Okay.
True. Yeah, but then all these skydiving, bungee jumping, you all have this how to say, safety precaution taken, safety measurements taken by professionals. So this one is safe. All right. So if you never try any free fall, to all our audience over there, never try any free fall at home, especially if you want to try, make sure it's safe to try. There are professionals beside you, only you try. All right.
So I just want to add on, like Malaysia, we don't have this called the warming comet muntah tau. In America, there are people you can pay to do it. There's a kind of a jet plane with a human being inside, so it fly up and it will follow a certain parabola to go down. And as you go down, got a few minutes, you are floating inside the cabin there, as if you are in a spacecraft floating. But that's called
that one we call it a 0 G flight. 就是失重飞行. A 0 G flight is actually the actual 0 G. Okay, it's more or less a minute, not a few minutes. More or less a few minutes. It will not be more than 90. It will not be more than 90 seconds. Okay.
But anything more than a few seconds is good. 90 seconds is a long time, you know, like. But you cannot.
Yes.
You have to pay for it. Okay.
So next we go into section B. All right. Section B, we select question number 2. Right. So this is we call Eclipse Visibility Map. All right. That means if you want to know whether your place is possible to observe eclipse or not, all right, you look at this map. Okay, you look at this map. So, all right. So the first thing, all right, it tells you time. So all this time, 这些时间, that means this time is the time where the greatest eclipse happened. All right, the greatest eclipse happened. So over here, the greatest eclipse happened over here. So that means over here, they will see annular. So that means within this region, I think I changed the color. One minute. And change color in color. Okay. So within this region, all right, within this region, oops. Right, within this region, the region of greater eclipse, all right, you will see the full eclipse, all right. So this one is full eclipse. That means you will see the fire, the ring of fire, annular eclipse. So slightly off this region, all right, then you see this blue line, the blue value 0.8, 0.8. That means you will see a partial eclipse, but 80% of the sun is covered by the moon. Okay, you will not see the ring of fire, but you will see a partial eclipse. So as further away from the center region over here, the greatest eclipse region over here, then you will see less and less. That means the sun is covered, less area of the sun is covered by the moon. All right, so the further it is, the lesser. So this value is actually we call the magnitude of eclipse. Magnitude of eclipse ，so 中文就叫十分10分。那么就是中间这一个点，这一条线中间这条线，它是最大的10分会发生的线。那么越往上或者越往下，就离开这个越远，就10分就越小。也就是说，月球遮住太阳的面积就越来越少所以这个值就是10分。And then another thing is to know where can we see. So basically all this blue line, okay, the region between these two pink line, okay, the region between the pink, within this pink line and the blue line, okay, and covered by this blue line, 就是说这个粉色的线这边到这边都是可以看到的，然后这边到这边。So this is the region, all right, 就是 within this region, if you are located inside here, 就你在这个地方，任何这个范围任何一个点 ，you are in this region, any point in this region, then you can observe the full eclipse from the very beginning until the very end. Okay, and over here, the pink line. Okay, let me clean a bit. So the pink line, there are L1 and L2. Okay, there are L1 and L2. L1, L2. So what is L1? L1 means at this point, so solar eclipse will start here. The very beginning will start here and then will end here. So that means when the solar eclipse ends, the solar eclipse will end during sunset. Okay, so the people in this region, in L1 region, they will observe the solar eclipse from the very beginning until the end. But when the solar eclipse ends, is during sunset， 就是在日落的时候月偏食，也就是说月食结束的时候刚刚好是日落。Okay, so solar eclipse end during sunset. And then L2, okay, L2 that means over here is further away, so that means it's later, all right, because the Earth rotates this way. Okay, so over here 就这里它时间会比较早会比较早，就是现在假设说我们现在这边是9点晚上9点，我们在这边晚上9点，那么这边在这一带的人就晚上8点，然后晚上7点，所以这边的时间会比较早，就比我们快So they are 1 hour ahead from us. For people in Korea, Japan, they are 1 hour ahead from us. So before the solar eclipse end, all right, before the solar eclipse end, they already have experienced sunset. 就是说太阳已经落山了，但是这个日食还没有完日食还没有结束，太阳已经落山了。就是在这一边的话 ，OK, so L2 refers to sunset, maximum eclipse during sunset. Maximum eclipse during sunset. So the pink line on the right hand side over here is solar eclipse end, all right, at sunset. So this line represents sunset. On the other side, on the left side, which is on the western side, all right, this one is sunrise. So that means over here, okay, 在这里这里 the solar eclipse begin during sunrise. OK, 就是日出的时候太阳就是刚好日食刚开始日出。那中间这一边 sunrise at maximum eclipse, OK, sunrise at maximum eclipse. That means 太阳出来的时候就是日环食，就是 它的时分最大时分啊。然后在这一边呢，就是sunrise sunrise 日出的时候 sunrise when the solar eclipse end 就是日出的时候，就是它的日食已经差不多结束了，就是一个这样的情况。And then asking about time, so there's a trick over here. So if you realize the time all given here is UTC. UTC. Okay, UTC. If convert to Malaysia time, you have to add 8 hours. That means you are 8 hours ahead of UTC. So if this is 8 o'clock UTC, that means it's 4 o'clock in Malaysia. 4 o'clock in the afternoon. That means 8 plus 8 hours is 16. 16 Malaysian time. That means 4 o'clock in the afternoon. All right. So that's the final part of the question. If you look at the map correctly, then you will realize that, okay, the first one, there are 4 locations asking the time to observe the maximum eclipse. So the first one is Xiamen in China. So China is this big portion. So Xiamen is over here. This is Xiamen. All right. The second one is Malaysia. Kuala Lumpur, Malaysia. So Kuala Lumpur is here. All right. If you observe carefully in the map, 就是如果你仔细观察的话，我们已经把这个地标已经给标出来了啊。That means we already make markings on the map. So Malaysia is here. And then the third one is Lhasa, Tibet. So Tibet is here, right? Tibet is here. So looking at the time, so Lhasa is here. It's between 7 to 7:30 UTC, somewhere in the center. So it should be 7:15 UTC. So 7:15 UTC plus 8 hours is 3:30 in the afternoon Malaysian time. So the time for Lhasa to observe is 3:30 in the afternoon, approximately 3:30 in the afternoon. Okay. And then Muscat, Oman. All right. Muscat is a Arab in the Middle East country. So it's over here. All right, Muscat. All right. So that's it on that's about briefly about how to read a solar eclipse visibility map. Yeah. All right. So Dr. Chong, maybe you summarize a bit.
Yeah. So yang itu Mr. Lai sebut tadi ya, ini berkenaan dengan gerhana matahari anulus cincin. Mengapa? Pada masa gerhana cincin itu matahari besar dan bulan kecil sikit. Jadi tengok satu gelang yang cerah, the ring of fire lah. Alright. Jadi dalam soalan dia Mr. Lai tanya mana berkenaan dengan apakah, I just summarize saya buat itu ringkasan. Ada garis-garis merah ialah di mana the maximum the annular part of the eclipse lah. Dan pun ada garis-garis biru itu dan lokasi-lokasi ya. Dan sekarang di sini tengok, di sinilah tumpu kepada apa? Benua Asia continent. Tengok Malaysia di bawah sana, Indochina, India, Arab Saudi dan kiri ialah Afrika. Jadi di sinilah masa itu ada nampak di garisan merah ialah gerhana matahari cincin, gerhana matahari anulus. Yang lain itu garisan-garisan biru itu gerhana matahari separa. Alright. Jadi akan mula di Afrika, sunrise start in Africa, tamat matahari terbenam, sunset somewhere in the West Pacific. Jadi there are a lot of details he asked lah, tempat-tempat macam di KL ke, di Xiamen, di China, di Muscat, di Oman, alright, di semua tempat itulah. That's it lah.
So nombor ini is called magnitude.
Yeah. Magnitude bermaksud apakah keamatan gerhana. What is the intensity of the eclipse? How strong is the eclipse? So the bigger the magnitude, the bigger is the eclipse. The stronger is the eclipse. The more the sun is covered on the longer time magnitude. Okay. So yes.
So all eclipse 全部的日食甚至月食都会有这样的图出现。So that means the visibility map, okay, is available for solar eclipse and also lunar eclipse. All right. So if have chance, we will show you on lunar eclipse, but not now.
So I just add on now. This eclipse map is possible because of what? Microchip. Now 300 years ago, when Isaac Newton came up with the law of universal gravity, already they can predict eclipses. So now solar eclipses, lunar eclipse can be predicted thousands of years into the future, and can be back predicted to thousands of years in the past, plus or minus 1 second accuracy. I can predict an eclipse, solar eclipse, at 5,000 years from now, accuracy of 1 second. Why? With the law of gravity, with the computer, I can predict it, and it's very accurate. Why? Because the motion of the, imagine this is the sun, all right? The earth orbits the sun, all right? And the moon orbits the earth. It follows this law of gravity, which is very, very accurate. That's why it can be predicted. Very accurate, by law of gravity with the silicon microchip. Okay.
就是简单的，说，就是你可以预测未来过去5000年到未来5000年会发生日食的时间那精确度到达1秒。
Yeah, plus or minus 1 second.
So, next, we proceed to next question, Dr. John.
Now, this one, I really like this question. Like, thank you for posting this. So, because now remember, this is in the part 2 of the quiz, section B, which is 5 subjective questions. So, this is a question, but there are answers. I will not, quote the question here. I'll just mention a bit, and I will give some of the answers, interesting answer given by the student. I won't mention the student name. So, basically, accident in space. I explain in English. So, on the left, imagine there's either an Angkasawan, Malaysian Angkasawan, or taikonaut, China, cosmonaut, Russian, or astronaut, American, doing a repair job in the ISS, all right? So you have a long Canada robot arm, made in Canada. So now the robot, the astronaut is doing a repair. So he's holding in his hand a drill, a gurudi, a drill. So now suddenly he make a mistake. So he detached himself from the robot arm. So now this astronaut, is floating away from the ISS. So now suddenly the astronaut is stationary in space, same distance from ISS. He has a problem. What's the problem is all the other 5 astronauts, cosmonauts in the ISS cannot help him. There's no way. So this astronaut must think of a way to make himself go back to the ISS to be safe. And here the question said that this astronaut has a cordless electric drill in his hand. Remember, a cordless drill is quite heavy, okay? Run by a battery. So he's now floating outside there. What should he do? All right? So the correct answer should be this. Now he is facing in the wrong direction. So basically, correctly is that he must make himself, the face of the astronaut must face away from the ISS. That's the first part. And then he has to push the drill, cordless drill, away from him, so that when he pushes away from him, he will go backwards. So what is it? You see, I imagine this is the apple is the astronaut. This this is this white thing is the drill. So the astronaut push this drill away, then this astronaut will move this way. So what is called? Never mind, boys and girls, primary school. This is the law of conservation of total linear momentum. Hukum keabadian jumlah tenaga linear. So now the astronaut and the drill is here. The linear momentum is 0, not moving. So now he pushes it away. So now this drill goes this way to maintain the same 0 linear momentum. The astronaut must move to this side. Then he goes towards the spacecraft. So basically, it's like this. Remember, right now the astronaut is floating, is hanging in space, not directly away. So he should make his hand. He must rotate in such a way that now his body will come to a move. Then his face will move face away from the ISS, and after that, he will take the drill and push away from him at the waist level. Waist level. Why? Because the center of gravity of any human being is at the waist. You may say, why don't you push here? He can push, but then he'll be tumbling towards the ISS. The impulse must be through your center of gravity, then you go in a straight line, chanting. You will hang it, not you throw it away from the center of gravity, then you will tumble. Can also but not nice, kepala pening. So he should push it linearly. So in other words, he must move himself like that to face away from the stage of ISS and push it at the waist, the grudi. Then he go back. So that is the full correct answer. But some of them came up with very ingenious answer in a sense. Not to say I didn't expect it, but they answer like that. I give them marks. That is, one person said, very ingenious, no? You take an object, you bocorkan into spacesuit, you pierce the spacesuit, then the spacesuit goes. So imagine the gas of the spacesuit, the air going this way, so the astronaut go backwards. But remember, you must make sure that the gas will come out so that the air in the spacesuit cannot be evacuated too much. Let's say after 1 hour, no more air in the spaceship, the angkasa will meninggal, die lah. So hopefully within a few minutes, they can go back. So because we know that they are present human being in a vacuum, from 1 atmosphere to a vacuum, you see people can survive up to 90 seconds. 90 seconds without any air. All right. Doesn't mean that when in 1 minute, no, in your vacuum, your lungs, the water will boil off, the blood will boil up. No. Still can survive for about 90 seconds. So hopefully, if we can have the gas pierce from the spacesuit opposite go away, the Angkasa one can go towards ISS, and then the other astronaut in this ISS open the door and they can go in. So it can save that day. So they give marks also. But the astronaut will give all kinds of interesting answers. One said, I take the gludi, I point at the place at the ISS, I on the gludi, I will go towards the ISS. No way. According to basic physics, you point the drill at it. Now remember, the drill will rotate one way, you know. So if you hold the drill this way, you are holding it, that you don't have any support on your leg, you know. So if the drill go this way, the Angkasa will rotate the other way. So but you remain in the same position. There's no way you can go towards it. So you point the drill at it and you open, you point it at the ISS, also you cannot go back. So basically, as I said, that was the answer. A very interesting question. So basically what? That's a basic physics understanding. Okay? Our Newton's law of motion, hukum-hukum Newton, 3 hukum, dan hukum keabadian momentum linear. Okay? Law of conservation of total linear momentum. Okay? Yes.
那么就简单的翻译一下哈，就是总结一下，就是怎么样能够安全的回到这个空间站里边呢？就其实是这样的，就是它其实就是2个原理，一个就是牛顿的3条定律1、2、3条定律，还有就是动量的守恒 （Conservation of Linear Momentum） 动量的守恒。那么其实就是首先这个航天员他需要背向国际空间站或者背向这个空间站。背向空间站之后，把他手上的电钻往前抛往前抛的时候会产生一个反作用力，反作用力就会让他自己往后倒。那么往后倒的同时就会倒到这个国际空间站上面就到了这个 ISS 上面，所以他就基本上就回到 ISS 上面了。那么他抛出这个小电钻就无线电钻的时候要注意一样东西不是在头上这边抛。也不是在胸口上面抛，而是在他腰间在腰中间，就是 around the waist. All right, you push away the cordless drill. Why? 为什么？就是因为一个人你的重心的位置center of gravity 重心的位置大概就是在你的腰的部分所以你从腰间把你的电钻抛出去的时候，那么你往后倒的时候是会直线这样一条直线这样往后倒。但是如果你往就是你在从头上那边抛的话，那么你就会旋转就是差不多这个样子旋转那么再补充一点，就是其实有好多很有趣的答案，就是我们在阅卷的时候判卷子的时候，我们看到很多很有趣的答案 a lot of interesting questions. For example, they say有同学说就是用电钻在那个航天员的这个衣服上面钻几个洞，那么这个漏气就是钻洞之后会漏气的时候自己就变成像一个小火箭这样往回倒。So the astronaut drill some holes on the spacesuit, so turning himself into a mini rocket. and move backwards towards the ISS. All right. 这个想法其实不太安全it's not safe to do so, but it's a good idea. So we give marks for that. So 我们也给分数，因为这个想法确实是可行，虽然不太安全，但是可行但是有的同学说，就是我打开那个电钻就是那个电钻开始转动的时候，这个非常危险因为我们有一个东西叫角动量守恒。角动量守恒的意思就是说，如果一个东西它是顺时钟转的话，它会有另一个部分需要逆时针转。也就是说，如果航天员打开那个电钻，那个电钻顺时钟转那么这航天员本身他的电钻假设他的电钻是这样子转，看我的笔他的电钻是这样子转，那么航天员本身他就会这样转，就像我的飞机它本身就会这样子转，反方向的转。 那么它还没回到，它这样转的话啊，它打开电钻的话，它不但回不了这个空间站，它反而会在太空中无限的啊，在那边打滚打转啊，起旋啊，就回不到空间站。所以这个打开电钻的话是不行，但是它需要有这个反作用力让它回到这个空间站啊，所以这个反作用力是关键，是重点。
Like I just add on,
Yeah.
In the history of manned space exploration, this has happened many, many times. What happened? For example, in the earlier Russian Mir space station, or now in the ISS, there are astronauts, men or women, doing spacewalk, doing the repair, starting up. And they're holding a tool, a big plier, a big spanner, and some of the hand tools costing hundreds of thousands of US dollars. But they're doing the repair, suddenly, left. The object left the hand and went into space. You know, cash, gone. 200,000 US dollars gone. Important equipment. So this has happened quite a lot of time. The glove, all kinds of things has gone, except that don't have Uncle Sawan left in space. Don't have a human being left. That's why when you do a spacewalk now, they always have a harness. There's a kind of a rope, tali, that hook to the ISS, and they are floating in space. Hook. Many years ago, the Americans tried that. It's a man maneuvering unit, MMU. He's still on the chair, and the chair got pressurized nitrogen gas. So he's free floating. They're outside on the gas, and the astronaut is sitting on the chair. So the astronaut can go many meters from the space the spacecraft and come back, but they're dangerous. So far, no astronaut, cosmonaut, psychonaut have lost in space like that. All right. So there have been cases where big object tools have been lost in space like that.
But sorry, Dr. Chong, this question is interesting, but I don't like the solution because you're creating a lot of space junk.
Correct. Dangerous. Now some of the boys and girls may say, but sir, the object leaving your hand is very slow. The spaceman is slow. No, remember at ISS is orbiting around the Earth at 8 kilometers per second. 28,000 kilometers per hour. So that object that leaves the hand of the astronaut is a super bullet, So it hit another rocket coming opposite direction. So it's dangerous. So this space junk is dangerous. So in other words, you are an astronaut in space. You're lost in space. You are a bullet, You are traveling at 28,000 kilometers per hour. Dangerous. If an object costing, say, 80 kilograms, man's weight, smash into a big building, the building will fall into bits. Dangerous. Okay.
Yeah. So our audience have a question for this actually. They ask, why don't they add mini jettison on the spacesuit to avoid these kind of problems?
Actually, it's a good comment. Actually, one of the students said, why not you can get a mini thruster to fire opposite away and to push it back to the ISS. But you must look, the question said clearly that the astronaut now is doing the repair on the robotic arms and he's holding a white cordless view. Suddenly, he make a mistake and he left the robotic arm and he's free floating outside the ISS, maybe 20 meters away. Same is like floating in space. And in his hand, he only has an electric drill, cordless drill. Now, don't have a mini thruster. Don't have a James Bond thruster. He only have a drill. So what must he do? To go back now. So you're not allowed. No mini thrusters is allowed. There's no mini thruster. So you know what? He has to think with his science. Oh yeah, I have a drill. The drill is I throw it this way, I'll go back the other way. That's it. No mini thruster, no hydrogen gas, no rocket fuel. Okay, it's given.
So no, I just add a bit of comment from the aerospace point of view. So why don't we have mini thrusters on the spacesuit? First of all, the spacesuit itself, the cost is very high. All right. It's about $500,000, all right, for one spacesuit. So because of the high cost, and then to adding a simple component, it might cost another few hundred thousands or a few 10,000s. So in terms of cost, it's not cost effective. 就是在经济方面其实是非常不划算、不实惠的。Number two, all the repair action is very near to ISS. So with the hooking of the umbilical cord, 就是套上这个安全锁的话，就是它可以到这个空间站的周围，那么它就不需要去到太远。That means the spacewalk doesn't need to go very far away. So mini thrusters is not necessary. So this is the two main reasons why they don't add mini thrusters into it. And then another reason is the spacesuit itself is already very bulky, it's very heavy. So even though in space is microgravity, you don't feel the weight. But then as a payload launching together with your rocket and your human inside, so every kg it costs a few 10,000 to few 100,000 in each launch. So if you add a component, you add the weight of the spacesuit， 就是说你加一个系统进去，那么你就加了重量，加了重量的后果是什么？就是你发射的成本就提高。That means the cost of launching will increase. So it's not cost effective and it's not necessary for the actual application. That's why in a spacesuit design, we rarely put in the mini thrusters.
So adik-beradik kita tahu nak lancar dari permukaan bumi 1 kilogram dari bumi ke angkasa 400 kilometer di ais saja, 1 kilogram pun berpuluh-puluh ribu dolar tau. 1 kilogram from the Earth surface to ISS maybe 10,000 US dollar, 40,000 ringgit, you know. So 1 kilogram to go there is a what? It's a small Malaysian car. So very expensive. All right. Anything to go 1 kilogram is very expensive. So you have a human being 80 kilogram. Wow, very expensive. Yeah. So now, Mike, your last question.
Okay, so now we move to the last question. Is journey to the space. So rocket is a common vehicle that is used to send astronauts into space, mainly to the space station. So list out the flight sequence of a human-rated rocket for crew flight accordingly from time t equals to 0 seconds until it docks with ISS. That means the question is asking the whole flight process from the very beginning, t equals to 0 until it docks with ISS. So what happens between from t equals to 0 until the docking? All right. So over here, I simplified it into a 10 steps flight sequence. All right. But then to be simple, let's watch a video. All right. Let's watch a video of rocket launch.
Not too long, right?
Yeah, a few minutes.
Okay.
Okay. So using the recent launch Shenzhou 12 mission. All right. So now is the countdown. All right. So they count down. So the first one is ignition. So you need to fire the rocket. All right. So let's see. Fire the rocket. After you fire, it will not immediately lift off. The second step is lift off. That means the rocket leave the ground. 就起飞起飞. So between ignition and lift off, there are a few seconds. All right. Because you need to gain enough thrust for the rocket to lift off. After lift off, it will go to the next step called programmable maneuver, or we call program turn. That means you see the rocket is not straight anymore; it's slightly turned, it's slightly slanted. This is we call program turn. All right, so it will turn towards the east. All right, turns towards the east, so it's slanted now. All right, it's no longer vertically straight; it's slanted. Okay, so after that, because this is a human-rated flight, that means there are human inside. Okay, so the next one, that means the escape tower. Right, the escape tower is a life-saving system. Right over here, the escape tower, 逃逸塔, Chinese we call 逃逸塔. So the escape tower, usually after 2 to 3 minutes, depends on the variance of rocket. All right, so this is lift off, programmable turn. And then after that, all right, over here you see, it's turn. The turning is getting more and more obvious. All right, so this is about 90 seconds after flight. All right, so still flying. Okay, 90 seconds after flight. So usually within 3 minutes. All right, that means until 180. Then the escape tower. All right, escape tower jettison. That means the escape tower will drop. Okay, will detach from the rocket. That means the rocket is safe. All right, that means the rocket will not explode in the mid-air. So the rocket is safe. When confirmed the rocket is safe, then only the escape tower will be detached. So now, okay, escape tower detached, it means the launch is 50% success. 就一半成功了. Okay, after that, okay, after escape tower, detach, then the boosters. Okay, it's about time for the boosters to finish. Okay, the fuel in the boosters is finishing. So after escape tower jettison,逃逸塔分离就是助推器分离。So the next one is the boosters. All right, you see the boosters is dropping off. All right, so boosters off, remove. All right, remove. And then after boosters, then is the first stage. So the first stage, we have the first stage. So before the first stage separate from the second stage, there are two things. First, the first stage must turn off its engine, switch off engine. So the fuel of in the first stage finish, and then the engine off. Okay, so engine off. After engine off, only it will separate. All right, so you can see this one is the second stage. All right, so this one is the second stage. So when the first stage is off, it will detach. At the same time, when it detach, the second stage will ignite. So ignition of second stage. So this one is the second stage. This one is the fairing. All right, this one is the fairing. Okay, so first stage have removed, have dropped off, and then the fairing will open. And the second stage, okay, 就火箭二级会继续推着我们的飞船向前。that means the second stage will continue to propel our rocket. Okay, but then by that time, because it's already going to the space, so no more atmospheric drag, so they can remove the fairing. Why we want to remove this all this part? To make our rocket lighter, 就是减轻重量。减轻重量的结果就是我们可以更节省能源。Okay, so after that, so 4 minutes of launch. Okay, so after that, okay, a few more minutes, the rocket will go into the desired altitude, desired orbit. All right, desired orbit. So before detach, all right, we need to close the engine. So the second engine shut off, the second stage shut off. Okay, so second stage engine shut off 就是二级关机，关机之后它才会进行 the most important part, which means the successful of the launch， 就是最重要的一个环节是船舰分离，就是飞船跟火箭分开 ，separation of the first stage, the rocket and the spaceship, the second stage and the spaceship. So that this mark or this indicates the success of the launch. All right. So over here haven't yet. Okay, it still have a little bit of time. Okay, and it separates. So after separates, it doesn't mean that after the spaceship goes to the space and it will directly dock. No. Okay, it have to fly, orbit the Earth a few rounds. 所以它必须绕地球先转几圈，然后再对接就是在绕着地球转的时候要进行轨道修正that means you need to have orbital correction before it meets the ISS or meets the space station and for docking. All right, so this is about the whole process of this flight sequence. So this is it. Dr. Chong, maybe you...
I want to add one more comment as we go to the award of the announcing the prizes. So basically, to fire a rocket from the Earth's surface to go to the Tiangong station or ISS, you are firing a bullet to catch another bullet. The first bullet is the space station orbiting around the Earth at 28,000 kilometers per hour, and then you fire a rocket from the Earth's surface at zero velocity, increase to match the velocity of the space station, which is 28,000 kilometers. So you're actually firing a bullet to catch up with another bullet, and all must match, same velocity, same direction, and then only. So not easy. So it's a technology not easy to master. So basically, for man docking, there are 3 countries, America, Russia, and China have successfully developed this technology for manned space exploration. That's all. Okay, right?
Okay, so launching a rocket is not as simple as you imagine. So in future, actually in future there are a lot of live session on rocket launch now. So if you have chance, 你们有机会的话，其实可以看一下。现在就关于火箭发射有很多直播，所以你们可以去看一下，大概了解整个过程。So this question is basically is to ask on the whole process, the general process of a rocket launch. So all the human rated rocket, that means with manned mission, the Russian, the American, the Chinese, the process of the rocket launch is the same. The general sequence is the same. All right. The only special thing I'd like to point out is SpaceX. Okay, if you realize that SpaceX Dragon Crew spaceship, the launch using the Falcon 9 rocket, all right, there is no escape tower. This is the special part because the whole the whole the whole spaceship is seated on top of the rocket, and the whole spaceship itself acts as the acts as the escape tower, is the life-saving system. So this is the innovation of Elon Musk. So this is something special. All right, but the other conventional rocket we have now, we have the escape tower.
Yeah.
All right. So let's see if we have any questions.
Now our Mr. Elon Musk got a competitor, George Branson. And later on, Jeff Bezos also lah. Okay.
Okay. So if we don't have any questions, I think we proceed to our simple closing ceremony.
Okay, Lan, closing ceremony.
Okay. So we have a simple closing ceremony. So first we invite our co-organizers, representative from Penang Science Cluster, PSC, Miss Amira Najiha, to give a simple speech.
Okay, thank you, Lai. First of all, I would like to congratulate all the participants and winners for your effort and also hard work. I believe it is not easy unless you give some effort on this competition. And also, not forgotten to thank the organizer, Astronomical Society of Penang, for do this kind of the program. I hope we can see this program next year again. And also, I hope that all the students learn and gain something new, especially related to astronomy knowledge. Okay, so all the participants and also winners, don't give up and keep up a good work. Okay, all right. So that's all from me. Thank you, Lai.
Next, we invite Dr. Chong.
Thank
to
you,
give
Lai.
a simple speech.
Terima kasih, Amira. So first of all, I'd like to thank our ASP committee lah, to make this possible. Just to let you know, this is the third year we are doing astronomy quiz for primary school. Tahun ketiga, right? So this year we are doing, so our committee, we have to thank them. Of course, we have our technical person and our treasurer, Mr. Michael Teo, indispensable. Thank you, Michael. I call Mr. Lai Hong Jun and me, we set the question, and our committee and a full support from our ASP member as well as the community. And of course, we would like to ucapkan terima kasih kepada Penang Science Cluster, right? So we had this Penang Science Cluster, this support and funding, alright. And first I would like to thank Datu Yun for Penang Science Cluster, Mr. Wee Teng Yi, CEO of TechDome, Cik Amira, senior staff there, Miss Amy Lee, alright, Cik Diana, Mr. Dong Jun. So they were a good team to support us. So just to let you know, we would like to promote this quiz for primary school. Next year we are doing for secondary school. More and more and better standard, so that we can motivate more of our Penang students, improve the education standard. Now remember, we have also our society, we have promoted International Astronomy Olympiad. There have been to three astronomy International Astronomy Olympiad. That's for the higher level, but this is of beginners level. So I see the past years, primary schools, they are very keen. So we hope that this will create the momentum for us to go forward. So terima kasih ASP member, terima kasih Penang Science Cluster, Amira, Diana, terima kasih.
Okay, so now I think we reached the moment that everyone is waiting for, 就是大家都万众期待的一个时刻, which is results announcement. So I first would like to invite Miss Amira to announce the results of the 5 constellation prizes of this quiz. So yeah, Amira.
Okay, thank you, Lai. So I will start my presentation first. Okay, I hope everyone can see. I believe everyone are waiting for this. Okay.
Yeah, I can see. Amira can see.
All right. Okay. So let's go to the. Let's go to the Consolation Prize. So for the Consolation Prize, it goes to Wang Jishan from SJKC Hanqiang. With the score, number 1 is 53 and score 2 is 49. And the total score is 102. Next one, for the Consolation Prize, we goes to Muhammad Faiz bin Anwar from SK Kepala Batas With the score 1, we have 53, and score 2, we have 50.5, and the total score is 103.5. The next one, okay, so the next one, we have Muhammad Qaim bin Ahmadi from SK Sungai Dua. With the first round 1 score, we have 53, and second score we have 54, and the total score is 107. The next one, we have Rafael Damain Mirza Ben Zulkifli from SK Batu Lancang. With the score 1, 55, and score 2 is 57, and the total score is 112. Last, for the Consolation Prize goes to Yu Her from SJKC Patient with the score 1 is 58, and also score 2 54.5, and the total score is 112.5. All right, so for the Consolation Prize until there, and I pass back to Lai.
So once again, all right, congratulations to all our Constellation Prize winner 恭喜就是这个安慰奖的获奖得主。那么 next we are proceeding to the top 5 winners. So let's invite Michael from Astronomical of Society of Penang.
Michael is waiting and waiting for you.
Yes.
Okay.
To announce the results.
We thank
Michael?
everyone. Selamat petang adik-adik dari 同学们，大家晚上好。For following, I'm going to announce the 5 winner, the 5 main winner. We have 5 main prizes. Okay, so we have the top 5 students. We have the highest combined mark from the both round. Okay, 所以接下来呢，我们会有5个主要奖项的优胜者。那么他们5位呢，就是这2轮比赛里面呢总分加起来是最高的。Okay, yang kita sekarang ada 5 orang pemenang utama, yang mana maka jumlah maka mereka dari dua-dua pusingan adalah paling tinggi ya di antara 20 peserta pusingan kedua. So tempat kelima, okay, ding. Okay, Chong Yuk Hong dari SJKC Wen Kai. Okay, maka pusingan pertama 51, pusingan kedua 63, jumlah maka keseluruhan 114. Okay, 第5名是钟玉红，来自文凯小学。Okay, 第1圈的分数是51，第2圈63，总分114，恭喜。Okay, fourth place tempat keempat di 4 名。Okay, Chia Jovi dari SJKC Perempuan Cina. Okay, maka pusingan pertama 60, kedua 56, jumlah maka 116. Okay, 第4名是Chia Jovi，来自滨华小学。Okay, 第1圈是60分，第2圈56分，总分116。Okay, third place tempat ketiga. Makin dekat siapa champion. Okay. Sitada Analati Wasupilai dari SJKT Mak Mandin. Okay, maka pusingan pertama 50, pusingan kedua 68.5, jumlah maka 118.5. Okay, Tania. Okay. Second place, dua lagi, deng. Ada music main belakang.
I can hear people shouting already.
Jangan jerit terlalu kuat Okay. Jeff Teo Yu Zhe dari SJKC Kiao Guang. Okay. Maka pusingan pertama 50, pusingan kedua 70, jumlah maka 120. Okay. 第二名是 Jeff Teo Yu Zhe， 来自 SJKC 乔光。首圈的分数是50分，第2圈70分，总分120分，恭喜。好的，ini dia yang tunggu 1 jam， tunggu ini saja。Okay. 所以接下来最后yang last kali kita akan umumkan champion, tempat pertama, first place, the top student of the whole competition, we score the higher marks from round 1 and round 2 combined. So the winner is, pemenang ialah Hafiz Danish bin Ahmad Fazli dari SK Payang Lepas. Okay, maka pusingan pertama 54, maka pusingan kedua 73, jumlah maka 127. Okay, Tania, congratulations.
All right, so I think that's it about the results announcement. So yeah, Michael, are we going to announce again the team prize, or we
Uh,
just proceed?
the price I didn't know, yeah, because we
Okay.
yet to, yeah, we have to check on
So,
the status first.
Lai, announce a bit about our online activities. ASP online
Okay.
activities. Announce.
So I think that again, congratulations to all our winners. All right, you all did a good job, and even the others who did not win, at least I believe it's a very good experience for all of our participants. All right, I hope instead of thinking of who is the winners or what did you win through this quiz, I sincerely hope that what you all think is what I have learned from this quiz, what I have gained from this quiz. All right. So before we proceed, Dr. Chong, any comment for the results?
So I think more or less what I expected. But I would like to tell the young people of Penang lah, whether you are in whatever school, primary school, or you are about to go to school, kindergarten, go to school. So basically, the standard of astronomy education in Penang is not bad, compared to many places in Malaysia. We are doing well. So we hope that the students in Penang, primary school, in secondary school, there's a lot of things to learn astronomy, serious. So one day join my society. Pertubuhan Astronomy Pulau Pinang, Astro Society of Penang. 槟城天文学会, come and join us, all right? And a lot of activities we do it right with Penang Science Cluster. We bring you to Penang Science Cluster to do activities also, right? So now is our society of online activity. And another thing is, for those who want to join our society, you go to Facebook, you can join us. Or you see us, we can give you the borang, right? So remember, jangan tertinggal, don't be left behind. Astronomy is very exciting. Everywhere we go.
Dr. Chong, sorry, I have a correction. So the winner just now, Afis is from SK Bayan Lepas 2. I always miss out the 2 behind the school name. So it's not Bayan Lepas, but Bayan Lepas 2. Okay, so sorry about that.
Bukan Bayan Lepas pasukan kedua, Bayan Lepas 2. Not the
SK Bayan Lepas 2. Yeah.
It's a Bayan Lepas 2, not team 2, Bayan Lepas 2. Yeah. Yes. So tanya Afif, okay, good. So come and join us. So astronomy is very exciting. All right, no end to the excitement. Okay, okay. So that's about all. So we hope again, Amira, please tell Dato Yun, what you call CEO, Mr. Wee Peng Yi, that we hope next year and next year remember we hope to taraf kebangsaan. Lebih banyak kepala pening. Okay.
Okay, so I think this marks the end of our quiz for 2021. So next year, 2022, we will have the quiz, but it's for secondary school. And for primary school, we will see you again in 2023, which is 2 years later. So yeah, for our potential participants, we have another 2 years to prepare. All right, so all the best and good luck. And we wish to see you again 2 years later. And just a little bit of information about our society is because under current condition, we have a lot of online activities. So on every last Saturday of the month, we will have the airport session. All right, we discuss selected astronomy photos. And for information, this airport session actually contribute a lot to our quiz question. So if you did follow our airport session, you actually can find that some of the questions we already discussed the answer in the airport session. So in future, this is one of the method you can use to prepare for yourself for the quiz. All right.
Just to add on, so those of you who are listening, who are astrophotographer, sorry, not for the boys and girls in primary school, so Michael Teo will be announcing soon. I will be hosting for this year Astrophotography Contest 2021. All right, with prizes and so on. We got some sponsorship, and the winners of it will have their winning entries put in our astrophotography calendar 2022 for next year. So wait for the announcement. Astrophotography Contest 2021 soon, and we will decide by November who are the winners for the Astrophotography Contest 2021 run by the Astronomical Society of Penang. Okay, so please everyone, stay safe and take care. All right.
Yeah. So welcome everyone to follow our Facebook page. or subscribe our YouTube channel for more information. So I think that's all for tonight. Good night, everyone. Thank you and good night. All the best. Have a nice day. And once
Terima
again,
kasih.
congratulations to all winners.
Congratulations again to all
Bye-bye.
the winners. Okay,
Yeah.
hope to see you again. Bye bye.
OK，tahniah，恭喜你。OK。